Integrated circuits. Page 8 of our textbook goes into a discussion of integrated circuits. Before we get there, though, we want to back up just a bit and talk about the transistor. Transistors are the core building block of computers. This may seem hard to wrap your head around, but let's look at a transistor and talk about what it is. Fundamentally, a transistor is nothing more than a switch, or a gate, if you will, that controls the flow of electricity. So the current flowing through a transistor is either on or off. And by assembling lots and lots of transistors, you can create circuits where the flow of voltage is controlled by a program. I know that doesn't make a lot of sense right at the moment, but hopefully as things progress in the class, that'll start to make a little bit more sense to you. So digital computers were initially made with vacuum tubes, and then transistors were invented. Transistors then were, shall we say, let's just say that they evolved, and that the concept of integration came about, which allowed us to place lots of individual transistors onto a single circuit chip. These were called integrated circuits. Now this particular video that we're going to look at is called The Making of a Chip, and it talks about the Intel manufacturing process of how integrated circuits are actually made. So I'm going to narrate this as we move through it. So to start off with, integrated circuits are made out of sand. Silicon is the second most abundant element in the Earth's crust. And regular old sand has a high percentage of silicon in it. So that's what all semiconductors or computer chips start out as, just basically as sand. So the sand is melted until we get silicon. So this is the process being shown here, is they melt it and they create a cylinder, what's known as an ingot. So they pull this ingot up out of the melting process. Now the next thing they do is slice it into some very thin wafers. The wafers themselves are very, very thin. Each wafer is about 300 millimeters in diameter and about 1 millimeter thick. The next step that we see going on here is applying photolithography. It's a process where a specific pattern gets imprinted onto the wafer. So they coat the layer on there, and then what they do is they take and photo etch a pattern onto the wafer. And in your book on page 8 it talks about photolithography, and that this is the technique that makes integrated circuits so spectacularly successful. So they are literally printing the wires and all of the other parts onto the chip. And there are very large numbers of these circuits on each of the individual wafers. You can see the idea here that there are lots of them on there. The next step is a rather peculiar thing where they put the ions in there. They often call this doping. I'll let this move along here. We're going into a very close-up view of how they actually etch out the material in the creation of a 3D transistor. This is an example of how a resistor works. A three-dimensional resistor, a gate that controls the flow of electricity. So that's like a single transistor being visualized right there. Here we have electroplating going on. This is where the metal is deposited. And after that, they put it into a solution. And then they polish the whole thing up. So that the underlying wires are exposed. There may actually be up to 30 different layers of wiring on these individual chips. Then they test them. They slice them up, and pick them up out of there, and put them onto a circuit board, and there you have an Intel microprocessor. The amazing thing about these integrated circuits, these processors, like these Intel processors, now have, I believe if I remember correctly, in 2015, the current state is somewhere in the neighborhood of 15 billion transistors on a single integrated circuit. That's a lot of transistors.